Just look at these insulation bats. Lightweight and easy to carry. A thin layer of this stuff throughout your home does an amazing job of reducing your energy bills, and compared to this mineral wool stuff, it's twice as efficient. Who would think then that this simple stack is such a nightmare to deal with? This PIR insulation is so expensive for such a simple product, so you have to somehow avoid any wastage with your cuts. It's horrible when you do cut it. You have to find a way to do it quickly and efficiently. The thermal aspect of a build has now become one of the most important aspects to get right. Breathability, vapor control, air tightness, thermal braking, building regulations approval. So we need to understand its relationship with both energy, environment and comfort. I'll show you my way of managing this process, from accurately quantifying the stuff in order to buy the exact amount for your home project, to minimising wastage and avoiding having these offcuts by planning your structure and the most efficient and painless way to cut this stuff. Here's the sheets arriving, and these are PIR sheets by Eco. There's also Celotex, Kingspan, Unilin, Nauf and a whole load of other brands. The prices change all the time, so I'll flick between these websites and see what the best deals are. The two things you need to check for are that they're foil faced or tissue faced, and just use tissue faced for warm roofs and bonding a roof membrane directly onto the insulation, and that they have a lambda of 0.22 or better, and this will always be listed on the manufacturer's websites. You'll have your target U value you're aiming for, R value if you're in the States, and which you'll get from the energy section of your building regulations. And you'll get your thickness required, that's 60 millimeters, 80, 100, 120 and so on, from tapping that into the online calculators on your chosen manufacturer's website. Here I need to insulate this floor for this small house build. Here's my target U value from my local building regulations standards, and here's my floor calculation meeting the required U value, and here's the depth of the insulation that I need. And here's how I calculated the quantity using my materials spreadsheet. And if you want to download a copy, just visit my link below at buildbetterthings.com. So with my insulation delivered, here's how I plan and then cut my insulation sheets the easy way. And warning, don't start with the insulation. Start with the frame you're building, which your insulation sits in. Most important is that I plan my floor, roof joists or wall framing so that it coincides with the dimensions of a full-size insulation bat. These are usually 2400 by 1200 millimeters, so I can get multiples of 600 and multiples of 400 without any wastage on the cuts. 4 cuts of 600 or 6 cuts of 400, and that means instead of putting my joists at 400 or 600 centres, I'll be putting them in with 400 or 600 clear spaces between, and that means I've got no wastage. What's more, I know I'm going to get a super tight fit for the insulation and avoid those nasty cold spot air gaps. Back to our timber frame, adding the thickness of our joists into that 600 or 400 multiple gives us the optimal spaces for our cuts. And here my floor joists are 45 millimeter thick, so I'll be setting them out at 445 millimeter centres. I could also go for 645 centres, but for my floor you must do everything possible to avoid bounce. Bounce leads to squeaks. Squeaks drive you crazy when you're sitting relaxing in your home. So I'll always go for smaller centres, 400 spacing between the joists. Check out my video here on how to set out your floor joists perfectly before adding your insulation. Now, because I know I've set my joists up, I don't need to measure anything. I'm just going to be cutting 6 equal strips of 400 millimeters from my boards. I'm going to use this permanent marker that's easy to see and mark my 400 millimeter running dimensions. So that's 4, 8, 12, 16 and 20 along my tape. Always be sure to use running dimensions and never use 400 each time individually because it's just inaccurate. I'll lay them out on the pallet they were delivered on, always cutting in the outside air to maximise air circulation, and get a mask and eye protection, gloves as well. It's horrible stuff to cut. Then I'll mark lines using my pen marks and a straight edge, and then I'll start to cut. Now I've tried all sorts when cutting these PIR boards. The problem with a handsaw, once you're above say 40mm in thickness on the boards, is that the saw blade is flexible and despite your very best efforts has a tendency to wander, giving you verticals that are, well, not vertical, and when it comes to fitting them between your joists it can be difficult to impossible, and then you find yourself having to cut tiny little slithers to fit the insulation between, but that in turn is going to create air gaps on the other side and potential thermal transfer routes. Now there's special saw blades, jigsaw blades. I've seen homemade jigs to keep the handsaw vertical, but the best way, the simplest way and the quickest way is to use your circular saw and set an old blade to maximum depth and cut through the first side of the board using your pen marks, then flip it over, mark your lines again and make your final cuts. You can see how quickly I'm cutting here, and in no time at all I've created 6 perfect insulation bats, and these PIR sheets are going in between my floor joists, and as we said earlier, in order to reach my U value I'm having to choose insulation boards which are thicker than the depth of my floor joists. Of course I'd love to do a detail where the insulation runs under the joist continuously, but I don't have the luxury of that additional solum space due to my height restrictions. Insulation is never easy. Now to fit these bats so they're not sticking above the floor level, therefore I'm going to use these plastics packers to space down my supporting battens to create the depth required to keep the insulation below the floor level, so my chipboard flooring boards can go over the top with no problem. Now using 25mm battens, I'll start off with a 50mm screw and my packer, fix at the other end in the same way, and then go along each floor joist, fixing with my nail gun diagonally, sticking into the joist and making sure to catch the packer with the nail. Where I'm going longer than 1200mm with my spans, I'll introduce another batten so the PIR is supported even at the cuts. I'll cut all the boards, and with a hammer and timber block I'll tap each of the cut bats into the spaces down to the supporting battens, and you can see how tight a fit I'm getting and how there's no need for any trimming. Everything fits perfectly first time because we've taken the time to plan out the timber floor to suit the dimensions of the boards. I'll fill in all of the smaller gaps by just cutting up my 400mm wide boards, and then I'll tape them up using foil tape so I can be sure that no vapour is transitioning into the fabric. I'm also using these Eager Protect boards, which, as long as the joints are all glued with expanding glue, will also act as effective vapour barrier. Belt and braces with my foil taping. For ordinary non-coated chipboard I'd go for this vapour barrier and tape it down. It has a highly effective reflective thermal coating. It is true that the majority of any vapour will go upwards and outwards, but it's so little time to get this vapour barrier sealed. I don't know why you would ever shortcut this part. Vapour control and air tightness in these new builds where you're using these super insulated PIR boards is becoming more and more important to avoid interstitial condensation and air leakage. Now using this method I get the entire insulation cut and fitted in less than a day, and now it's time to fit my chipboard. And I'll show you how I organise and plan that out in the next one. It would be a big favour for me if you could hit that thumbs up, it really does help me, and I hope to see you next time.